Morning everyone. Today I'm going to explain the sum about simply separated view. This is a given diagram. Impact grade and massive 500, which is severe exposure. Wall thickness 350 mm. The first step to do is geometry. Effective length equal to 7000 plus 350. 350 is the wall thickness that is given. Then LEF equal to 7350 mm. Then we have a formula span by D. Where formula span by D equal to 20 by IS 456 page number 37. As we assume span by D equal to 14, D equal to span by 14. That equal to span length is 7350, which is found by 14. That gives the value D equal to 525. Then we find out D effective cover, which D effective cover equal to nominal cover, that is NC plus main diameter by 2 plus stirrup dia. This formula is in IS 456, page number 47. So we get nominal cover equal to 45. Stirrup dia equal to 8 mm and main dia equal to 32 mm. Then D dash will, that is effective cover, D dash equal to 45 plus 8 plus 32 by 2, which gives D dash equal to 69 mm. Then D overall depth equal to, like, we will find out the overall capital D, which is D plus D dash that we found out, which is equal to 530, 594, which we assume nearby value is 600 mm. Then D plus D dash equal to 600 equal to, as D value will change after getting the main capital D. So we'll take D capital D equal to D plus D dash, which is 600 equal to D plus 69, which gives us D equal to 531 mm and B is 350 mm. Then we move on to the next page. The second step is analysis, where cells weight equal to D into B into 25. That equal to D is 0.6, as it is in meters, we convert it, and then into 0.35 and into 25, which gives 5.25 kN per meter. Live load equal to 20 kilonewton per meter. Combined both total load equal to 25.25 kilonewton per meter. Then we find out moment, which M equal to WL square by 8 equal to 25.25 into 7.35 whole square by 8 equal to 170.508 kilonewton per meter is the value which we get. Then we'll find out the shear, which is V equal to WL by 2, which is 25.25 into 7.35 into 2 equal to 92.79 kilonewton is the value which we got. Then we will find out MU, which is like for MU and VU, you have to take 1.5 and multiply it with the M and V as respectively. Then MU equal to 1.5 into M equal to 256 kilonewton per meter is what the value we got. Then for VU, 1.5 into M equal to 140 kilonewton is what we got. Then the third step is, till here the second step ends. Then the third step is adequacy. From SP16, page number 30, table D, you can find this MU by L by BD, MUL by BD square equal to 3.99. Then MUL equal to 3.99 into 350 into 531 whole square. You will get MUL value, which is 393 kilonewton per meter. MUL is always, there's a condition, like if you see the condition MUL is greater than MU, then it is simply reinforced. If the statement isn't right, then it will not be simply reinforced. Going to the next page. The fourth one is AOT calculation. That is area of steel required. In SP16, page number 50, MU by BD square equal to 256 into 10 excuse me, 10 cube into 10 cube by 350 into 531 whole square. Then you will get the value 2.59 and Newton per mm square. Then you have the table here 2.55, 2.6. You will find out which value is more nearer to the area. Then you will write it 0.659 plus 0. Brackets 0.674 minus 0.659 by 2.6 minus 2.55 into 2.59 minus 2.55. You will get the PT value. The PT value we got is 0.674. So we have a formula for PT. PT equal to 100 AST by BD. So we know the PT value here. So it is 0.674. Then you have 100 into AST by this formula we'll write here. We'll add the PT, substitute the PT value which we have got here. So 100 into AST by 350. We know BND 350 into 531. So we'll get the AST value of 1253 square. That is bottom. And then AST required we'll find out. We have a formula here which is in IS 456 page number 47. 0.85 BD by FY is the formula. So substituting the value of 0.85 into P and D values 350 and 531 respectively by 500. FY is 500. So AST minimum equal to 316 square is what we got. That is top value. So for the bottom, we will discuss, like we will see how many bars we should provide. So as per we will provide here three number of 25 diameter bar. So we'll get the AST provided by referring to IS code book. Then AST provided equal to 1472 square is what we got the value here. So PT equal to 100 AST by BD. PT equal to 100 into the new required value which we got. The value for AST provided which we got will substitute here 1472. Then B and D 350 into 531. So we'll get PT equal to 0.79. So then we'll calculate for the top AST minimum equal to 316 We'll provide three number of 12 diameter bars. Till here the fourth step is over. Now we'll go on to the fifth step, check shear, which check shear, which we'll find it in 73 page number and 456 as well. Then tau V equal to VU by BD, tau V equal to 140,000 by 350 into 531, which gives tau V value equal to 0.75 N by square. Then page number 73, as I told you before, which is in IS 456, tau C equal to 0.6 Newton per square. Then tau C max equal to 3.5 Newton square, where we'll have a statement here. Tau V is greater than tau C and tau C is less than tau C max. If this is if the statement is correct, then we will provide shear reinforcement. Then VUS equal to VU minus TC BD is the formula which gives us 140,000 minus 0.6 into 0.6 into 550 into 531. VUS equal to 28490 Newton, which gives us VUS value equal to 0.87 Fy. VUS equal to, we got the value, then VUS equal to 8.087 Fy by AST. S4 is the SY is the formula in which we will substitute the VUS value we got. So then we will substitute the other value 0.87 into Fy is 500 and then into 2 into 50 into 531 by SY. We don't know the spacing. So spacing we will find out. We got the spacing to 672 Then spacing max equal to, this is the formula, either it is 0.75 D or 300 So after calculating, we'll get the spacing as 300. As which is lowest, you should take that the value. If the value in 0.75 D is lesser, you have to take that value. Or if the value is more than 300, then you should take 300 as a spacing. Then provide 8 diameter bars with this thing. Then till here the fifth step is over. Then we'll move on to the sixth step, which is check for deflection. The formula here is actual span by d, that equal to, we have the actual span value and d value. So after substituting them, we'll get it as 13.84. Then we'll calculate allowable span by d. That is another formula, which is 14 into mf. As we don't know the mf value, that is 20. So then fs equal to 0.58 into 500 into 153 by 1472. Then we'll get the fs value, which is 245 Newton per mm square. mf equal to 1. Allowable span is greater than actual span. So the section is safe without deflection. Sorry, safe in deflection. So after it's done, this is the diagram for the problem. This is the structure for the problem. Thank you. This is the sum I explained. Oh, recording